In chapter 2, you have analyzed many different examples of motion. Motion in horizontal plane, vertical plane. You have solved problems using kinematic equations in both x direction and y direction. Every one of those examples were linear motion. Today, we are going to go beyond linear motion to projectile motion. Projectile is an object upon which only force acting on the object is force of gravity. Air resistance is negligible, that means the object is in free fall. Projectile motion can be identified in one dimension and two dimension. You have already learned the one-dimensional projectile motion. And the motion of an object is in straight line in one dimension. In two-dimensional projectile motion, the trajectory of the projectile is a parabola. When you solve a projectile motion problem in two dimension, you have to consider the variables in x direction and y direction separately. So let's start with the acceleration. Acceleration in y direction is the acceleration due to gravity. It is 9.8 meters per second. And the acceleration in x direction is 0 because nothing is pushing the object to the left or right. And then initial velocity in x direction is equal to final velocity because there's no acceleration. And in y direction, initial velocity is not equal to final velocity. The reason is there is an acceleration in y direction. So you cannot have the same velocity. And we use v naught y and vy as the symbols. And in x direction, we have a constant non-zero velocity because acceleration is just a 0. And initial position x naught, final position x, initial position y naught, final position y. Now let's look at the time. Time is the only scalar quantity. Time is independent from the direction. For that reason, you have the same time for the x direction and y direction. The time elapsed is the same. Okay, now let's look at the equations in x direction and y direction. In y direction, remember we have a constant acceleration, that is the acceleration due to gravity. So that means you can use the uniformly accelerated motion equations or else the kinematic equations you already know. But don't forget you have to use them in y direction. So the first equation, the average velocity is equal to displacement in y direction over time, and then you have to add the instantaneous velocity at the initial and final time, and then divide it by 2, and then you have the other equations in y direction. And then for the x direction, you can use just one equation because acceleration is 0, final position is equal to initial position plus velocity in x direction times the time. Now, as a summary, it's very important to note that there's no acceleration in x direction because nothing is pushing or pulling the object in x direction. And then the constant non-zero velocity in x direction. In y direction, you have a free fall, and then initial and final y velocities are different. Then time is the only scalar quantity. Time is same for both directions. Here I have a simulation from Gizmos. So I'm going to show you the motion of a golf ball, and you have to think about it. Ask yourself, how can you describe this motion? So when the object is in motion, the only force acting on it is force of gravity. The reason is I have chosen the atmosphere as none. There's no air resistance. And the object is in free fall, but this is a two-dimensional projectile motion. The reason is, if you look at the velocity of the object, it has not only a x component but also a y component for its velocity. The red arrow shows the x component of the velocity, and then blue arrow shows the y component of the velocity. Now think about this. What is this purple arrow? What does it represent? And then if you look at the screen, you can see there's a value for the x component of the velocity, and also there's a value for the y component of the velocity. By using the angle, how do you get the x and y components of velocities? And the acceleration, what is the acceleration of the object in y direction? What is the acceleration in x direction? And what happened to the velocity vector when the object is passing through the maximum height level? And look at the magnitude of the velocity vectors, the x velocity and y velocity. What happened to the magnitudes? What happened to the directions? Ask yourself, think about it.